So in this section, we're adding in a couple more shapes. We've got trapezoids, and then we have kites and rhombuses. You've seen the kite and rhombus formula before this year already, and I know you've seen this formula, just not this year. We haven't talked about it. So if we look at this sentence on the left, it says the area of a trapezoid is half the product of the height and the sum of the lengths of the bases. So if we want to put that in a formula, what would that look like? It says the area of the trapezoid is half, so we should probably have half there. Half the product. What does product mean? We're going to multiply something together. So we're going to multiply something times something else. What are we multiplying together, does it say? Okay, so we're multiplying the height and then the sum of the bases. What does sum mean? Added together. So we have to take B1 plus B2. So that's the trapezoid formula. The bases are just the ones that are parallel to each other, so they're not always the top and the bottom. They could be the left and the right, depending on how the trapezoid is drawn. But the ones that are parallel to each other are considered the bases. So if we're looking here, which ones are the bases? So is 5 considered the height? Okay, yes, the height is the one that's perpendicular in between the two bases. It connects the two bases together. All right, so looking at this, we have our 3 lines of work, which means we're writing our formula down first. You put the numbers in the right spot. We decided the height was 5. And the two bases, doesn't matter what order you put them in, you're just adding them together. And then we throw this in the calculator. Someone do that for me? No units on the problem, so no units needed on your answer. Now you're not always going to have all of the information you need, so there will be some situations where you have to do a little bit of side work to figure those out. So we'll go through some of those examples on the next page. Questions on this one? So looking at this one, do we have everything we need? Yes, we do. So we're just doing our 3 lines of work. Very straightforward problem. Height and the two bases. What's our number on this one? This one does have units, so we want to throw those units on our answer. Questions on that? So now we're going to look at 2 examples where we don't have everything we need and how we can acquire that information. Looking at this trapezoid, what information do we have? We have both bases, the parallel segments. Okay, so let's at least start our formula. I'm going to leave the height blank because we don't know that, but we know the 7 plus 10. Okay, so let's think about this. We know that this entire base on the bottom is 10. How far is it from here to here? If you look up above here, it's a rectangle, so we've got 7 right there. Which means what number is over here? Has to be 3, because the whole thing on the bottom is 10. So we have a right triangle. This is our perpendicular height. And we could use SOHCAHTOA, but we could use something even shorter. If this is a 45-degree angle and this is 90, how big is this other angle in the triangle? It's also 45, which means it's what kind of triangle? It's isosceles. 2 equal angles means 2 equal sides. What 2 sides are the same? This is 3. Okay, so use that if you're able to. You could have used SOHCAHTOA. It would have given you the same answer. If we throw this in the calculator, what do we get?
25.
Let's try one more. What information do we have? Again, we have the bases on this one. So I'm going to start by writing the formula. That's always the first thing I do. I figure out what shape it is, pick the right formula, write it down. Now I can start throwing the numbers in that I do know. I'm leaving the spots I don't know blank. All right, we're going to have a similar train of thought here as we begin this problem as we did up above. So we're trying to figure out this right here, the height. Now, how long is this one? We know that's 12 from up here. So that leaves what for this? That's 4, because the whole base on the bottom has to be 16. What do we have to do on this one? Which one is c squared? That's the important part of this formula. It has to be your hypotenuse. So you're going to use 8 over here on the right. This will turn out to be a decimal, I believe. We square root that? Over here, we know this is now 6.9, which means we put 6.9 right here. So please know that there's going to be some Pythagorean Theorem. There's also going to be SOHCAHTOA. We'll get to that later on in the chapter. So we'll review all of that. What is the answer for this one? How much? Inches squared. Questions on trapezoids? Yes.
The 1/2, is that 1/2 inches 6.9 or 6.9?
You can put this all in your calculator at once. You can put the multiply right in between the 1/2 and the 6.9, and it'll calculate it correctly for you. Other questions? Awesome. Let's move on to the other formula then. Okay, we're going to draw in the diagonals on these. The diagonals, remember, are the ones that go inside and connect corner to corner. Now, we talked about these two shapes in chapter 8. What do we know about those red lines? Tell me anything you know about them. There's a couple of properties that we know. Yeah. They are perpendicular. What else do we know? They're bisected. Okay, so on the rhombus, both of them get cut in half, but on the kite, just one of them does, right? Okay. Is there anything else? That's the majority of it. Okay. There's some stuff about angles, but we are more focused on the lengths of the diagonals. Okay, so the area formula, 1/2 d1 d2. Again, we've seen that this year, and it will be on your formula sheet, but you need to remember that that formula is linked to rhombuses and kites. So we're going to try a couple of problems on the last slide before we get to the homework. Okay, 3 problems total. So looking at the one on the left, we have a kite. Area equals 1/2 d1 d2, d standing for diagonal. We just need to put those numbers in. Now, what do we have to be careful of when we do this? Besides the parentheses. What do they mean by the diagonal? Should we put in 3? What do we need to be careful of? What am I getting at here? You need the length of both diagonals all the way from end to end. Okay, so we know one of the diagonals is what? 3 plus 8.2, 11.2. We don't know the other one, but the other one is the one that gets cut in half. So if we just find half of it, then we're good to go. Okay? We learned and remembered that that is a right angle. We know that is 3. They told us that. So what are we going to use? Another Pythagorean theorem. Which one's the hypotenuse? So we got 3 squared plus x squared equals 4.39 squared. Help me out with that 4.39 squared. Give me all the decimals.
19.272.
Okay. Subtract 9. And square root. Okay, so pretty close to 3.2. So what does that mean this other diagonal is? Remember, this right here is 3.2, so this is also 3.2, so 6.4. Make sure you use the entire length of the diagonal. So throw this in the calculator, and we have point what? Inches squared. Okay. The next one, there should be these dashes here to tell you that it's a rhombus. When you have a rhombus, it's really nice because we know both of the diagonals get what? Split in half. Okay, so when we're doing this, there's typically not Pythagorean theorem involved. Sometimes there is. This one there is not. We just need to make sure we use the entire length of both of those orange segments. So how long is one of them? 10. How long is the other one? 7. They just told us that this chunk is 3.5, so we have to double that. We get 35. We'll do one working backwards problem here at the bottom. But are there questions on those kites or diamonds? All right, so let's try this working backwards one. We still have our first step, which is to write down the formula. What shape is this? It's a trapezoid, so we're going to start with the trapezoid formula that we learned at the beginning. And now we need to throw in everything we do know. What do we know? Yeah, they told us the area, so we're going to put that over here on the left. Do we know the height? Make sure you pick 11, not 12. Do we know the bases? 9 and x. Now we're just trying to get x by itself. So we have to think about what we should do with the order of operations. What should we do? That would be a safe bet. Yep. So let's change this to be 5.5. So all we did was combine the 1/2 times 11. So now what should we do with 5.5? All right. So we've got, what's 5.5 times 9?
49.
So distribute the 5.5 to both terms. Now it's simple algebra, subtract and divide. What's this? And divide? 7. Any questions?